Yes, tonight is what you can see coming. We have an integral from 0 to 1, okay, 1 over x raised to the power 4 and x raised to the power 3 plus x raised to the power 2 plus x. And we're supposed to integrate this. So when we see such an equation or an integral expression, we can see the denominator carries a lot of exponent. Okay, so it's more, we say this is more polynomial kind of. If you look at a sketch of such a graph, y equals to, if we have y equals to x to the power 4 plus x to the power 3 to the power 2 plus x. This more polynomial kind of. So we can integrate it by using some kind of factorization. Okay, now let's set the ball rolling. So to work out this integration, let's see. Okay, now let's have a look at it. So the question says the integral of 1 x raised to the power 4 plus x raised to the power 3 x raised to the power 2 plus x dx. So as we saw earlier, if you look at it, it's more polynomial. So our concentration is to be able to break down the denominator so that we'll be able to solve this without difficulty. So we have x 4 plus x 3 plus x 2 plus x. And this, we can bring our x out like that. Let's break it bit by bit, and we have x cubed plus x squared plus x plus 1. Okay, then that is looking good. It's looking good. So why don't we bring maybe x out? Then we say this. Then we'll bring x squared out. Okay, if we do that, we are going to get x plus 1 plus 1 x plus 1. Okay, all into bracket that. And you know the middle part, we can further expand this one as x out x squared x plus 1. Okay, and x, no, let's break it further. Let's break it further. So I think it's a bit long. So let's try this way. So as we come down, so this and that are the same. So therefore we can say x out x squared plus 1 out x plus 1. Yes, that is what our factorization will be. Alright. So now let's put this one in a partial fraction. Okay, so our partial fraction is, so the expression itself, as we have been able to break, the integral after our integration is going to be this all over x out x squared plus 1 x plus 1, okay, dx. Well, in so doing, we can be able to solve it with ease, so that when we see we put in the partial fraction, then our expression will be equals to 1 over x squared plus 1 out x plus 1. Okay, now this will be a over x plus b over x plus 1, and our plus cx plus d. It will be all into bracket s squared plus 1. Alright, so as we multiply through by our denominator, x squared plus 1, x plus 1 throughout, then our equation will boil down to be equals to 1 is equals to a into bracket x plus 1 and x squared plus 1, and our b will be bx s squared plus 1, and the last bit will be plus cx plus d multiplied by x plus 1. Alright, so if we do that, that's what we're going to get. So we have ax plus 1, s squared plus 1, and the b will be bx x plus 1, and the last bit will be that multiplied by x. Okay, so let's look at it carefully. As we multiply through by that, we have this multiplied, the whole expression multiplied through by this one, and as we can see, we have ax, so the x will cancel the first value x here. Then we will end up having a multiplying x plus 1 plus s squared. Then our b, okay, this will multiply by x squared plus the whole thing again. So the x plus 1 will cancel. So our b will be that. Our b will be that. So b multiplied by that, then x plus 1, this one will cancel this. Then we'll be left with b x s squared plus 1. Then when we finish, you multiply through by the d. So the d, this s squared plus 1 will cancel that. So this multiply by x. Okay, so we have x here as well. Now, let's look at it from this point. So we have this to simplify. So what do? We have to expand everything. Okay, so we are going to expand it. All right, let's expand it. We have 1 is equals to a out s squared plus s squared plus s squared plus let's clean it and use a sharper pen. So this is a bit blunt. Okay, this we get a sharper pen. Okay, so now this one will give us s cubed plus s squared plus x plus 1 into bracket. Okay, so that's what we'll get for that. Then we get our b to be bs cubed. Bs cubed. Let's try and put all in one bracket. Okay, so that we have enough space. So into bracket bs cubed plus bx into bracket. Okay, then here we're gonna go cs cubed plus cs squared plus dx squared plus dx into one bracket. Now, when we do further separation, we have our 1 to be equals to ax cubed plus as squared plus ax plus a, okay, into bracket plus we are going to get bs cubed plus bx into one family. Okay, then we have cs cubed plus cs squared plus ds squared plus dx into 1. So now let's put all the a's and all the cubes into one side. So all the cube at one side, we are going to get our 1 to be equals to as cubed plus bs cubed plus cs cubed, okay, as 1. Then we have a s squared plus cs squared plus ds squared into one family. Then we have plus ax plus bx plus dx plus I in everything is equals to 1. Oh, so beautiful. It looks so plainy, but it's just a little. Okay, so if you look at it very well, so all what we have to do is to take good care of our multiplications. So this is as cubed. Okay, now let's separate. When we separate them together, we are going to get, the first one, we're going to get a plus b plus c equals to 0. Then we have a plus c plus d is also equals to 0. Then we have a plus b plus d is also equals to 0. Then the last one, a, is equals to 1. Okay. Then when we solve 1a, so now we know a is equals to 1. Yeah? Let's look at it. A is equals to 1. So a is equals to 1. 1a is equals to 1. 1a is equals to 1. Yeah? When we put in the values to this, we have a plus b plus c is equals to 0, implies that 1 plus b plus c is equals to 0. So that means b plus c is equals to -1. This we got to underline because we're going to use a letter. Because we underline this. All right? It's looking good. Now let's try the other one. When A is 1 again, okay, comma, we're gonna get A plus C plus D is equals to 0. So this implies 1 plus C plus D is equals to 0, giving us C plus D to be equals to -1. Okay, so let's call this ones some names. This one is equation 1, and this is equation 2. All right, let's do the third one. When A is equals to A once again, is equals to A. When A is equals to 1, we have A plus B plus D. A plus B plus D also equals to 0. This implies that our equation 1 plus B plus D will implies that B plus D is equals to -1. So we call that one equation 3. This is interesting. Really, really interesting. This is equation 3. So now, after that, we need to solve our equation simultaneously. Okay, so simultaneously, let's use our green one more. All right, so simultaneously means that if I have C plus D, B plus D, you know this one is equals to -1, and this also -1. So these two, if I subtract them, I'm going to get my C minus B, C minus B to be equals to -1 plus 1, that's 0. So meaning C is equals to B. Okay, let me highlight this. Isn't that beautiful? Now that we know C is equals to B, but we also know that, let me put this one here, blue. Okay. Now, since now we have C is equals to B, okay, so from 1, I can say that B plus C is equals to -1. So meaning B plus B is equals to -1, meaning 2B is equals to -1 implies that B is -5, then the half. Okay, we have that one too. So now we have value of B. Okay. Now, value of B. Okay. Now I know B is equals to -half. B is equals to -half, meaning that from 2, B plus D, and from 3, B plus D. So B plus D, B plus D is equals to -1, meaning if I substitute this, -half plus D is equals to -1, then our D is equals to -1 plus half. So D is equals to -half. Oh, interesting. Let us put this one around it. Oh, blue around it. Okay, so blue around it. So this is also one answer. Then the last but not the least, I would like you guys to write it down before I clean. Okay, I'm gonna make sure you write everything down, then I'll clean. So now I'm gonna continue. You ready? Because I'm gonna go move up. So we also know that we have A plus C plus D, which is equals to 0. So when we put in all the respective values in the equation, we are going to get 1 plus C minus half is equals to 0. Okay, giving us our C to be equals to negative half as well. Wow. So therefore, we've got all the values that we need for our partial fraction. Okay, so now we got to substitute the respective values into our partial fraction. Okay, so when we do that, since we know the first value A, now let's write the values we had. So our values we had for the A, we had 1, B minus half, C minus half, and D minus half as well. Okay, hence our partial fraction will be 1 over x, okay, plus minus half x plus 1, okay, minus x plus 1 all over 2 again, s squared plus 1. Good. So this is our integration. This is what we are supposed to integrate now. dx. It's beautiful, isn't it? So if we look at, let's categorize them. If we look at the integration very well, I'm going to call this one maybe P1, and this is P2 and P3. Okay, this is the integral. When we look at this one, I think to me we should break them down. So when we break the integral down, we're going to get the integral 1 over x dx minus half integral 1 over x plus 1 dx. Then we're going to get minus half again integral x plus 1 all over s squared plus 1 dx. Okay, so this is our integration. Straightforward, we can deal with P1 and P2. Then we have to look at P3. Okay, so now we all know when we integrate 1 over x, okay, like this, we are going to get the natural log of absolute value of x. The next one, the P2, will be minus half natural log of absolute value of x plus 1. Okay, now the last bit. Okay, let's demarcate it. This one, we need to solve it differently. And how do you go about it? Yeah, how do you go about it? Okay, so let's put it aside. So that integral alone, P3, we call it, we are going to express it this way. So that will be minus half out. That's how it is. Minus half out, bam, x plus 1 all over s squared plus 1 dx. Okay, so what do? Our denominator is s squared plus 1. And the top is also s plus 1. So I think the best way we can express this one is to break it into pieces so that we will say that this is minus half out. Okay, our integral is going to be integral, since we have x over s squared plus 1 plus 1 over s squared plus 1 all together dx. Okay, we have splitted the integral, so I will say split it. Okay, the integral. Okay, so our integral is split it. Okay, so now further more, since we know P1 and P2, they are there weighted. So P1 plus P2 are waiting for the rest. Now, let's substitute. So let U to be equals to s squared plus 1. Okay, s squared plus 1. So that meaning our du is equal to 2x dx. Okay, so when we substitute into the equation, we are going to get minus half out. Minus half out. We have our x over u dot du over 2x. And that simply will give us negative 1 over 4 integral du over u. You see, we have, so that as we broke it down, this is what we're concentrating on, this very one, because since we know we have x over x, so we're integrating them differently. So we're tackling this. As we tackle that, we know that this one will give us negative 1 over 4 natural log of u. Okay, so I think u, when we do the further substitution, okay, this negative 1 over 4 natural log of u, but our u is s squared plus 1, so s squared plus 1 is what we get for that. Okay, so now we are able to solve this one as well. Let me point it out. So this is the answer to this integral. Okay, now the last bit here. Now, how do we go about this? It's one, this one should remind you of something. 1 over s squared plus 1 integral. We can use tan inverse to do that. So that one plus our half is out already. So minus half is out already. So, you know, if I look at it carefully, since this one will be integral 1 over s squared plus 1. Okay, 1 over s squared plus 1. We have a minus half out already. Okay, so that when with this one, when we integrate this, okay, we know this can be written as minus 1 over 2 integral, then we say s squared 1 over s squared plus 1 squared dx. And this, when we integrate using the tan inverse expression, we are going to get minus half. Okay, then into bracket 1 tan inverse of x over 1. Good. So this eventually gives us minus half tan inverse of x. Right, so we are able to break the integration into pieces. So finally, our answer. So our answer is natural log. When we integrate, let me clean well space. When we integrate all this, okay, when we integrate all this one, we are going to get, what was the question? The question is 1 over x 4 plus s cubed plus x squared plus x integral dx. So our answer for this integral is equals to natural log of absolute value of x minus half natural log of absolute value of x plus 1 and minus 1 over 4 natural log of x squared plus 1, okay, minus half tan inverse of x. Whoa, it's wonderful. So this is what we get in this whole lot of the simplification we've done. Awesome. Well, friends, I think that is where we'll put the gear from the third, second to the first gear down to 0. So thank you very much for attending this class. Looking forward to see you again. But please go down there, click on the bell so that when we do any tutorial, you'll be the first person to receive it. Yeah? Thank you very much and subscribe.